Hi, it's time for another math easy solution. Turn discuss a video I should have went over a long time ago instead of now. Basically look at a overview of integration or integration overview and look at Riemann sums, antiderivatives, and integrals and basically see how they're all interlinked together. Basically I've made many videos on Riemann sums, antiderivatives, and integrals, but only ever somewhat separately. So I've made these separate, but I haven't really done an overview video combining them all together to show how they're linked. And I decided to make this video after being asked on YouTube, I think yesterday or a couple days ago, about whether Riemann sums are linked to antiderivatives. So I decided to make an overview video on integration to show how all of these concepts are indeed interlinked, because again I realized I didn't have a one video overview of all this, so might as well make it now. So to quickly recap on Riemann sums, let's look at that first. So Riemann sums, as I went over in my earlier videos, is just it's equal to this summation. So at I equals to 1 up to n. So it's a summation of the function f of x I star, and I'll get to the star in a bit, and then times it by delta x. So this is the Riemann sum, and then you could see this graphically like this. I'll draw the x and y like this. So let's say you had a function such as this over here, and this is our f of x function. Then we have, let's say at this point here, we have the point x equals to b, and this point here is x equals to a. And now the idea of the Riemann sum is basically, well, if we were to try to find the area underneath this curve, we're basically gonna sum up a bunch of rectangles. So let's just take let's draw a bunch of rectangles like this. So that's one, and here, let's get one like this, and all of them exactly the same width, delta x. So I'll draw this delta x like that, etc. So we're gonna draw this all the way about, and I'm gonna draw one here. Yeah, I'm gonna just draw one here separately. Actually draw it a bit higher up just for illustrative purposes, and then again dot dot dot. This is the one I'll use to draw some of the notation on it. So the last one here, let's draw this better line like that, and let's say it's something like this. Okay, let's say that they're all the exact same delta x width. Yeah, so what we have here is at this point, this is our xo, or x0, we'll call this is the same thing as a, so at x0 is a, here we have x1, then x2, x3, and then dot dot dot, keeps all the way going. Here we'll call this one at this very point, I'll get to that in a bit, so I'll do that at the end. Here we'll have xn minus 2, this is right here, xn minus 1, and the last one all the way to xn, where xn is just equal to b. So again, the idea is this just summing up a bunch of rectangles, doesn't matter, and then there's n rectangles. And then at this one here, we'll call this just a random point inside, we'll call this xi, and then at this point, xi minus 1. And yeah, I just draw that in blue, move that over. So the xi star is just any point inside these xi minus 1 and xi like that. So in this case, this is our xi star. It could be the midpoint, the side point, doesn't matter as long as it's on it. So this very point is xi star. Again, make sure to watch my earlier videos on Riemann sums to get more detail on that. So that's what that is. And again, this all has the same delta x width, so all of it's delta x. And this delta x right here, so this is also delta x. And this all equals to is just the width of each of these rectangles, and that's going to be b minus a, or the full length here, subtracted by here, and then divided by n parts, so that you have basically, n rectangles of delta x width. So that's what this formula is. And then at this very point here, this is just our f of x I star, like that. And then the area across this whole thing right here, we'll call this ai for the ith rectangle, and this is just equal to f of x I star, and then delta x times it by delta x width. So the width delta x is the rectangle, delta x times the height of f of x I star, and then if we look at this Riemann sum is just the summation of all of these rectangles for an n amount of them. And in other words, you could write this as, I'll keep it in blue, xi equals 1 up to n, and this is just, again, you could write this as a summation of I equals 1 up to n of ai, or the area of this rectangle, this generic rectangle, sum it up forever up to n total rectangles, and that's what this fxi star is. Same thing over here. In other words, so then this whole thing is basically roughly equal to the total area or net area, yeah, under the curve. So that's the idea of it. And again, make sure to watch my earlier videos on Riemann sums, get a better idea of this. So that's the Riemann sum. Yeah, now let's look at antiderivatives again. So basically recap on that. A function capital F is called an antiderivative of small case f right here if the derivative of the capital letter F is equal to f. In other words, this is you could write it as the derivative of this f right here is equal to small case f. Or if it's a function of x, you could write f, I'll just write it over here to save space, or f prime of x is equal to small case f of x, like that. In a quick example, i.e. is, let's say if f of x, just again to recap, if f of x equals x squared, then f of x equals to f capital F of x, x cubed over 3 is an antiderivative. Antiderivative of f. And this is because, well, we just take the derivative of this, because the derivative of f prime of x, which equals 2, well, derivative of x cubed, that's just the 3 goes down. So 3 over 3, because there's a 3 there. And then you subtract the power x squared, this cancels, that's just x squared. So there's our answer. Okay, that's our answer, and again, that equals to, let's write that again, equals to f of x, which is right over here. Circle that. Okay, so now that we've just recapped on antiderivatives, now let's look at integrals. So integrals, again to recap, an integral is simply the limit as n approaches infinity of a Riemann sum. So it's pretty much a Riemann sum. In other words, and it's also written like this. So you would write an integral from a to b of f of x, yeah, dx. This equals to the limit as n approaches to infinity. So again, it's just a limit as n approaches infinity. So you have an infinitely many number of rectangles. And again, since you're dividing delta x right here by n, or infinitely amount of rectangles n, then you're going to have an infinitely small delta x to fit in this infinite number of rectangles. Again, so make sure to watch my earlier videos on integrals and Riemann sums, again in the video links below. So this would be simply I equals to 1 up to n. So n is going to infinity, and this is f of x I star, because it could be any x value inside that interval, delta x. Alright, so now that I've recapped the integral's definition, or the definition of an integral, which is again limit of a Riemann sum as n goes to infinity, so that's like this. And now where we link everything together, that's from the Fundamental Theorem of Calculus, and I've gone over the proof of these again in my earlier videos, so make sure to watch those. So the Fundamental Theorem of Calculus, or FTC for short, links the integral with the antiderivative, and I can't emphasize this explanation mark more. Yeah, because this is a very, very important theorem. Let's put that. I'll make my own explanation mark like that. So it links together that. And let's recap. There's two parts of it. Part 1 of the FTC, or the Fundamental Theorem of Calculus, states that g of x is equal to the integral from a to x of f of t. This is just change variable because we have an x there. dt, where basically g prime of x, the derivative of g of x is equal to the integrand inside, just the variables are changed, f of x, like that. In other words, g of x is an antiderivative of f, or f of x. So that is quite remarkable. And again, yeah, these functions need to be continuous, etc. You can see all of those details in my earlier video on Fundamental Theorem of Calculus and its proofs, so make sure to watch that. And what this means graphically, or how you could view it graphically, is something like this. From x, this is t. We're just changing the variable because we're dealing with x, another x variable. So we have like this. Let's say it's a random function f of t, and then this is say the intervals from a to b, but we want to find the area up to x. So this shaded area, this is equal to g of x, which is the integral of this function f of t from a to x, which is quite remarkable. Let's write this down. Integral from a to x of f of t dt. So this is one of the most important theorems, well, in human history actually. And the reason is because it's easy to find the antiderivative of many functions, and then the fact that that becomes the area under, or the integral, which is quite remarkable. And now part 2 of the FTC is it's taken as this. Again, just to recap, so integral from a to b of, so this is looking at a definite value, so f of x dx, this equals to a subtraction of f of b, and then the f of b minus f of a. Yeah, and this is finding a definite number from a all the way to b, and that's finding this area across this whole thing, as opposed to just this x variable. And where this capital F of a and capital F of b, like that, I'll just write that down, where capital F, the derivative of capital F of x is equal to small case f of x. In other words, again, this capital letter f is an antiderivative. F is an antiderivative of f, or small case f. So that's the second part, and that's the first part. Again, make sure to watch my earlier videos on that. Yeah, so thus what we conclude is thus the FTC, let's write the Fundamental Theorem of Calculus, links the antiderivative and integrals together. Yeah, and or where the integral is just the limit of a Riemann sum as it goes to infinity. And again, note that the links to my earlier videos on Riemann sums, antiderivatives, and the Fundamental Theorem of Calculus are included in the video description of the video, so check those out for more detail. Anyways, that's all for today. If we learn from this overview, and then basically showing how all the antiderivatives are linked with the integral, where the integral is just a special type of Riemann sum, just as n is going to infinity. Anyways, that's all for today. If you learn, like always, you can download these exact notes and link below. And thanks for watching, and stay tuned for another Math Easy solution.